day, sir. I am Nicole Zamgidelos Reyes from BSE 2B. I am here recording this video to show you how I solved assignment Seatwork number 7. So in assignment number 7, the problem is preparing to figure 2, change RA to 0.2 ohms, RB to 0.3 ohms, and RL to 0.5 ohms with the same battery polarities, and with EA is equals to 24 volts and EB is equals to 26 volt. As shown, calculate A. the currents IL, IA, and IB, B. the load voltage, C. the load and battery power PL, PA, and PB using Norton's equivalent circuit. So, Norton's theorem. This theorem is analogous to Thevenin's theorem, except that instead of the open circuit test, this theorem uses the short circuit test, and the equivalent circuit is parallel circuit. So, given two voltage source, which is EA is equals to 24 and EB is equals to 26 volts, connected to resistor RA is equals to 0.2 ohms, and thus current A, RB is equals to 0.3 ohms, and thus current B and RL is equals to 0.5, and thus current L. So, step 1. Short circuit the load resistance RL and solve the short circuit current ISC. So, use KVL at loop ACFA. So, 24 minus 0.2 I1 is equals to 0. So, 24, then transpose 0.2 I1 to right side. So, 24 minus 24 is equals to 0.2 I1, then divide both sides. So, 24 cancel 0.2, cancel this one, then we have remaining I1. So 24 over 0.2, so I1 is equals to 120 amps. Then use KVL at loop BFEDB. So negative 26 plus 0.3 I2 is equals to 0. So transpose 26 to the right side. So 0.3 I2 is equals to 26. Then divide both sides by 0.3. Then we will now cancel 0.3 over 0.3. Then we will have the remaining I2. So 26 over 0.3. So I2 is equals to 260 over 3 amps. Now to solve, short circuit current it is equals to I1 plus I2. So substitute the value, 120 plus 260 over 3, then solve, we will get circuit current. Our short circuit current is equal to 620 over 3 amps. Now let's go to step 2. So in step 2, compute terminus resistance. So short circuit all the voltage source and open circuit the load resistance. To compute the terminus resistance, RO is equals to RA times RB over RA plus RB. Then substitute the value, 0.2 times 0.3 over 0.2 plus 0.3. Terminus resistance is equals to 0.12 amps. Now, let's go to step 3. So, in step 3, construct the Norton's equivalent circuit and solve IL. So, in this diagram, you can see short circuit current is equal to 620 over 3 and has terminal resistance is equals to 0.12 ohms and has RL is equals to 0.5 ohms. So, to solve IL is equal to short circuit current times terminal resistance all over terminal resistance plus R1. Substitute the value 620 over 3 multiplied by 0.12 all over 0.12 plus 0.5. So, IL is equals to 40 amp. Then, since we have the value of our IL, we can now solve for VL and PL. So, to solve VL is equals to IL times RL. So, substitute the value 40 times 0.5. Then, VL is equals to 20 volts. And to solve PL is equals to IL times VL. Then, substitute the value 40 times 20. PL is equals to 800 watts. Now, let's solve for IA. So, short circuit resistor RA, solve for short circuit current. So, short circuit current is equals to negative I2 plus I3. Then, to get, since we don't have the value of our I2, we can now use KVL equation at loop. So, 24 minus 0.5 I3 is equals to 0. It is our equation 1. And then equation 2, negative 26 plus 0.5 I3 plus 0.3 I2 is equals to 0. Then add equation 1 and equation 2. So 24 minus 26, it is equals to negative 2 plus 0.5 I3 plus 0.5 I3 is equals to 0. Then we can now cancel I3, or it will be cancelled out. So plus 0.3 I2 is equals to 0. Then transpose negative 2 to the right side. So 0.3 I2 is equals to 2. Then divide both sides by 0.3 over 0.3 I2 over 0.3. So 0.3 will be cancelled, I2 will be remain. So 2 over 0.3, we will get I2 is equals to 20 over 3 amp. Now let's solve for circuit current, short circuit current. So we will now use this equation. So ISC, or the short circuit current, is equals to negative 20 over 3 plus 48. Now ISC, or the short circuit current, is equals to 124 over 3 amps. Now compute the Norton's equivalent resistance. So open circuit RA and short circuit all the voltage source. So Norton's equivalent resistance is equals to RB times RL plus over RB plus RL. So substitute the value 0.3 times 0.5 over 0.3 plus 0.5. So Norton's equivalent resistance is equals to 3 over 16 ohms. Then In this diagram, we can now see that ISC is equals, or short circuit current is equals to 124 over 3 amps, and Norton resistance is equals to 3 over 16, and RA is equals to 0.2 ohms. So we can also solve IA. To solve IA, it is equals to IA is equals to short circuit current times Norton resistance all over Norton resistance plus RA. Substitute the value 124 over 3 multiply by 3 over 16 all over 3 over 16 plus 0.2. We will get IA is equals to 20 amp. Since we have the value of our IA, we can now solve PA. So PA is equals to VA times IA. So substitute the value 24 times 20. PA is equals to 480 watts. Now let's solve for IB. To solve IB, we will use or apply KCL. IA plus IB minus IL is equals to 0. Then simplify. So IB is equals to IA. IB is equals to negative IA plus IL. So substitute the value. We will now use these equations, or use this. After we simplify, we can now use IB is equals to negative IA plus IL. So then we can now substitute the value. So IA is equals to 20, or negative 20 plus 40. So IB is equals to 20 amp. Since we have the value of our IB, we can now solve PB is equals to VB times IB. So substitute the value 26 times 20. So PB is equals to 520 watts.